Hello, in this part of the video, I want to talk about some of my audio programming techniques, implementation techniques, and procedural sound design techniques that I've used in this level. First, let's talk about the audio POS system, which is the player-oriented sounds. This system is divided into two parts. The first part activates the system when the player overlaps with this blueprint. The second part uses the player's X, Y, and Z location to trigger sounds around the player randomly at a random interval. This blueprint is highly reusable by any members of your team and can be in various shapes like sphere, box, capsule. You can decide the extent of these shapes, as well as the time at which you want these sounds to be triggered. There's also a debug option which we will use now to see where the sounds are spawning around the player. I'm going to use a command called stat sounds, which gives an overview of all the sounds playing at any moment. There you can see the sounds spawning around the player. The next blueprint that I want to talk about is the shrub audio detection system. This blueprint is attached to the shrub in the level and is divided into three parts. First part is the pickup system, where the detection sound stops once the player has picked up the shrub. The second part is the detection system, as when the player overlaps with this blueprint, the detection sounds are turned on. The third part is the random fluctuation, which gives a 40% variation of the sound intensity and frequency. Let's see how it translates well into the level. I'm again going to use this command stat sound waves. This one also shows all the sounds but without the location. Now I'm going to move closer to the shrub and we'll see how the sounds play out. As you can see, the pickup detect sound has started playing. Now you can faintly start to hear them. The volume is increasing, and so is the frequency. It's going to be maximum when the player gets closest to the shrub. And it stops when the player collects it. The next blueprint that I want to talk about is this fairy op blueprint. I've used the parent blueprint to set up the interaction and the visual system. These interaction and visual systems were then embedded by default in the child blueprints. I then used the child blueprints to set up the Boolean dialog systems and the integer variable systems. I've covered these systems in detail in my playthrough in the gameplay. Next, I want to talk about my implementation technique through animations. I have used animations to embed sounds in them using sound cues. Let's have a look at one of the boss animations. I've used the sound cues to align with the visuals and also used varied volumes and pitches to give them more variation. I've used similar techniques for character and other NPCs as well. This gave me a chance to mix and also use similar sounds with different pitches and increase their reusability. Next, I want to talk about my procedural sound design techniques in the sound cues. I've used a layered approach for the Guardian Impact cue, where I've divided the sound into 4 layers. I've then passed these sounds through a random node to randomly select any one of them, and then pass them through a modulator node to give varied pitch and volume. These are then mixed through a mixer node and again passed through a modulator node for a varied effect. In my player-oriented sounds, I've passed cricket chirps to two different random nodes. One of the random nodes is passed through a delay node to delay the sound by 100 to 200 milliseconds. The frog sounds are passed through a random node, and I've added 3 empty inputs in them, so sometimes the frog sounds are not played when the cricket sounds are played. Finally, I want to talk about some of my sound design techniques that I've used for this project. These are a series of videos which I've already released on my social media, and you're more than welcome to explore them. You're also more than welcome to see all of my YouTube tutorials in details for my programming techniques. I hope you've enjoyed looking at my project, and this is everything from my side. Thank you very much for taking the time to go through this project. Hello. Today I want to address a very important topic in sound design: creature sounds. We often find it difficult to emulate creature sounds with our own mouths, but this can be done very easily by using a simple technique called time stretching. So I have this reference cricket chirp in my project here. I'm just going to play it now. Okay, now I'm going to slow it down to 8 times and play it again. That still doesn't sound right. What you need to do is uncheck this preserve pitch when changing rate. Now that is something that can be emulated. So now I've made my own recording. That sounds terrible. I'm gonna speed it up 8 times. And again, make sure I uncheck the preserve pitch. Not bad, is it? I hope you like the technique and you can use it in some of your own projects. Thank you.